What if everything you thought you knew about World War II tank combat was backwards? For decades, we've been told the Sherman was a death trap, that it took 5 Shermans to destroy 1 German Panther, that American tankers died in their thousands inside inferior machines, while German supertanks dominated battlefields. It's one of history's most persistent myths, and it's almost completely false. The real story is far more fascinating. When German engineers captured their first Sherman in North Africa and sent it back for testing, they initially celebrated. Finally, proof of American mediocrity. Thin armor, a weak gun, mass-produced garbage. But then they started driving it, and their smiles disappeared. This tank didn't break down. It didn't shed transmissions after 200 kilometers like Panthers. Its engine didn't catch fire randomly like Tigers. German test reports documented something their Panzer crews would learn to fear. American automotive engineering had created a tank that simply refused to die. Not from superior firepower or thicker armor, but from something far more terrifying: reliability they couldn't match, and production numbers they couldn't overcome. If you want to discover how the Sherman won the war through engineering brilliance hidden in plain sight, hit that like button, subscribe, and drop a comment telling me which tank you think was truly the best of World War II. Now, let's demolish some myths. When the first M4 Sherman tanks rolled off production lines at 11 different factories across America in July 1942, German intelligence analysts barely registered concern. The Wehrmacht had spent 3 years fighting Soviet T-34s and KV-1s, French Char B-1s, and British Matildas. Another Allied medium tank wasn't going to change the fundamental calculus of armored warfare, or so they assumed. The Sherman specifications seemed to confirm German dismissiveness. Armor thickness maxed out at 76 millimeters on the front hull, pathetic compared to the Tiger's 100 millimeters or the Panther's sloped 80 millimeter glacis. Main armament consisted of a 75 millimeter M3 gun that couldn't penetrate heavy German armor at combat ranges. Weight came in at just 30 tons, making it lighter than every German heavy tank and even some mediums. To Panzer crews accustomed to their technologically sophisticated Tigers and Panthers, the Sherman looked like exactly what Nazi propaganda claimed it was: mass-produced American junk. Quantity attempting to substitute for quality. When German forces captured their first intact Sherman in Tunisia during early 1943, engineers at Wehrmacht testing facilities conducted thorough evaluations. They measured armor angles, test-fired the main gun, examined the suspension system, and assessed crew ergonomics. The initial reports contained exactly what German high command expected to hear. Armor was inadequate against German anti-tank guns. The 75 millimeter gun posed minimal threat to Panthers or Tigers in frontal engagements. Crew survivability would be poor against modern German weaponry. But then, the German test drivers actually operated the Sherman for extended periods, and something unexpected appeared in their reports. The transmission didn't fail. The engine didn't overheat. The suspension handled rough terrain without breaking track. After 500 kilometers of testing, then 1,000, then 1,500, the captured Sherman kept running with only routine maintenance. German engineers, accustomed to Panthers shedding final drives after 150 kilometers, couldn't quite believe what they were documenting. The secret hiding inside every Sherman wasn't exotic metallurgy or revolutionary armor schemes. It was something far more prosaic and infinitely more deadly: decades of American automotive engineering expertise applied to military vehicle design. While German tank designers came from artillery and heavy machinery backgrounds, Sherman engineers came from Ford, General Motors, and Chrysler. They'd spent the 1930s perfecting mass production techniques that could build reliable vehicles by the millions. The Sherman's transmission exemplified this philosophy. German tanks used straight-cut gears that were cheaper to manufacture but required perfect synchronization and wore out rapidly under combat stress. The Sherman used herringbone-cut gears, the same design found in millions of American automobiles. These gears meshed smoothly, tolerated driver error, and lasted thousands of kilometers without replacement. It was unglamorous engineering, the kind that didn't win design awards, but it meant Sherman crews could execute emergency maneuvers without worrying their transmission would explode. Engine reliability told the same story. Panthers used the Maybach HL-230, a theoretically powerful 700-horsepower V12 that in practice barely reached 1,000 kilometers before requiring major overhauls. Early Panthers at Kursk in July 1943 achieved only 16% operational readiness, with more tanks lost to mechanical failures than Soviet anti-tank fire. The Sherman's radial aircraft engine, or diesel variants, ran for 3,000 kilometers under proper maintenance. German mechanics needed specialists and rare parts to keep Panthers operational. Sherman crews could perform most repairs with basic tools and standardized components that were identical across thousands of vehicles. By January 1945, the Panzer Commission reported catastrophic numbers: 500 defective Panzer IV final drives, 370 defective Panther drives, 100 Tiger failures. These weren't tanks destroyed in combat. They were vehicles abandoned because German industry couldn't produce spare parts fast enough and crews lacked the training to perform complex repairs under field conditions. Meanwhile, American armored divisions maintained 90 to 95% operational readiness rates throughout the European campaign. More tanks meant nothing if they spent more time in repair depots than fighting. The production numbers revealed why German Panzer commanders grew to dread the Sherman, despite its inferior specifications on paper. Between 1942 and 1945, American factories produced 49,234 Sherman tanks across all variants. 11 different manufacturing plants, many converted from locomotive or automobile production, churned out Shermans at rates that seemed impossible to German intelligence. At peak production in 1944, American facilities were completing over 2,000 Shermans per month. Germany's most comparable medium tank, the Panther, never exceeded 300 units monthly, even with Albert Speer's desperate mobilization of slave labor and underground factories. Total Panther production across the entire war reached approximately 6,000 units. The Tiger, Germany's heavy tank legend, topped out at 1,347 produced. Simple arithmetic made the strategic picture brutally clear. Germany was building tanks one at a time using skilled craftsmen, while America was stamping them out like automobiles using assembly line workers. This production philosophy extended to every component. Sherman parts were standardized and interchangeable. A transmission from a tank built in Detroit fit perfectly into a hull manufactured in Illinois. German tanks required custom-fitted parts with serial numbers matching specific vehicles. When a Panther's final drive failed in France, mechanics couldn't simply grab a replacement from another damaged tank. They needed the exact part specification, often unavailable, forcing crews to abandon otherwise functional vehicles. The myth that 5 Shermans were needed to kill one Panther emerged from German propaganda and post-war accounts by tankers like Belton Cooper, whose memoir Death Traps colored perception for decades. But when the U.S. Army Ballistics Research Laboratory conducted detailed analysis of actual combat engagements, they discovered something remarkable. In documented armor versus armor battles between M4 Shermans and Panther tanks, the kill ratio was 3.6 to 1 in the Sherman's favor. Read that again. For every Sherman destroyed, American crews knocked out 3.6 Panthers on average, the exact opposite of popular mythology. This kill ratio advantage stemmed from factors German tactical doctrine hadn't anticipated. American combined arms tactics emphasized coordinating tank movements with artillery, tank destroyers, and air support rather than relying on individual vehicle superiority. Sherman crews were trained to immediately report enemy armor positions and withdraw while calling in artillery or airstrikes. Panthers, despite superior frontal armor and firepower, spent most engagements defending positions where American forces held tactical initiative. Statistical analysis revealed another crushing reality. Defending tanks enjoyed massive advantages regardless of type. Every combat study showed defenders scored more kills than attackers, whether comparing Shermans versus Panthers, Panthers versus Shermans, or T-34s versus anything. German forces spent 1944–1945 conducting defensive operations, which should have maximized Panther effectiveness. Yet they still lost tanks at unsustainable rates, primarily because mechanical failures eliminated more Panthers than enemy fire. The Sherman's crew survivability, supposedly its greatest weakness, actually exceeded German equivalents in practice. Yes, Shermans caught fire when penetrated, earning the grim nickname Ronson from crews. But German tanks used gasoline engines positioned in crew compartments and carried ammunition without proper separation. Panthers experienced catastrophic engine fires so frequently that crews learned to evacuate immediately when engine temperature gauges climbed into danger zones. Tiger crews faced similar risks from fuel systems prone to leaking under combat stress. More importantly, Sherman crews who survived vehicle loss could be assigned to replacement tanks within days because America had surplus vehicles available. German tankers whose Panthers broke down or were destroyed often couldn't receive replacements for weeks or months. By late 1944, experienced German armor crews were being reassigned to infantry units simply because no tanks existed to crew. The Wehrmacht was losing the war of attrition not because German tanks were inferior, but because they couldn't keep them running or replace losses. By March 1945, the strategic picture had become undeniable, even to the most fanatical Nazi commanders. American armored divisions were operating hundreds of Shermans across France and Germany with minimal mechanical losses. German Panzer divisions existed primarily on paper, their tanks abandoned along roadsides with blown transmissions, empty fuel tanks, or engine failures that couldn't be repaired without parts that didn't exist. The Shermans' influence on post-war armor development vindicated American design philosophy in ways German engineering never achieved. Captured Panthers were evaluated by Allied forces after the war, and French Army reports from 1947 concluded the design was fundamentally flawed. Insufficient driver training caused accelerated mechanical failures, but even well-maintained Panthers couldn't match Sherman reliability. Soviet designers examined both tanks extensively and adopted American-style standardization and ease of maintenance for their post-war T-54 and T-55 series, which became the most produced tanks in history. More than 50,000 Shermans equipped not just American forces, but British, Canadian, French, Soviet, and eventually dozens of post-war nations. Shermans fought in the 1948 Arab-Israeli War, the Korean War, and were still seeing combat in the 1973 Yom Kippur War, 30 years after production ended. Panthers were scrapped as soon as the war ended because nobody wanted to maintain them. That alone tells you which design actually worked. The greatest irony is that German engineers knew the truth. Their own test reports from 1943 onwards documented Sherman reliability advantages. Captured intelligence showed American production numbers that made German output look pathetic. But Nazi ideology couldn't accept that American quantity over quality democracy had produced better tanks through superior engineering fundamentals. So they kept building complex, unreliable Panthers and Tigers while convincing themselves that technical sophistication would overcome industrial reality. It didn't. The Sherman won World War II not through superior firepower or thicker armor, but through the unglamorous virtues of reliability, mass production, and engineering competence that kept tanks running when it mattered most. German Panzer crews learned too late that wars are won by tanks that fight, not tanks that sit broken in repair depots, waiting for parts that will never arrive.